Anytime you try out some new equipment, you're always in for a treat when you start looking at your data. What we have here is we have an image that I stacked last night without flats, and this is what we're looking at. See that big dark thing in the corner? That is the installation of my new ZWO off-axis guider. That's the little shadow of the prism that is inside there that reflects the light up to your guide camera. So in this video, what we are going to do is we're going to take some flats and we're going to see how easy this is to correct all at once together. This is a first for me and it could be a first for you. Shouldn't be too difficult, but that is always the last words. Welcome back, all 70 of you lovely people, to the Easy Astro Image channel. I am Chad. Let's get outside here and let's take some flats and let's get this rosette looking a little better, huh? Okay, so we are in Nina. I've got everything fired up and running, and I have a directory set up for my flats. I've got the camera cooled down to pretty much the same temperature, minus 10 degrees. You're not necessarily have to do that, but I like to keep everything as consistent as possible. Then I want to do these things called dark flats at the same times too. So it's going to take my flats at a certain percentage and time. Then I'm going to cover up the scope and it's going to do the exact same thing with the dark flats. And we're going to use those to help process out all of this craziness that you see here. The window, the prism, all that kind of stuff, dust modes. I set my histogram at like 30%. I want longer than a second. 1.1 seconds is what I'm at right now. I'm just using a white t-shirt and a cheap Amazon flat panel. It seems to work very well for me. I'd like to have one of those fancy spike flat things one of these days, but they're a little too pricey. So we are ready. Our 50 flats are done. I'm going to go outside and cover up the scope, and we're going to take our dark flats. Okay, now our dark flats are shooting, and as you can see, they pretty much just look like bias frames. They are going to be subtracted from the flat to create a master flat, which will then be used with the master light to help calibrate everything. Tonight it is super cloudy, so since I have the camera set up, it's cooled down, everything like that, I'm actually going to take advantage of this opportunity to add to my dark library. I have about 10 to 15 30-second, 240, 180-second exposures, but I really want to expand that out so we can average things out and make our images look even better. So we'll let this thing continue off and we'll be right back. So after running all of our images and our flats through the weighted batch pre-process, this is what we have. And actually this looks better compared to the previous 3 or 4 times that I tried this morning. I found out that my flat panel is broke. I was getting some really weird lines inside of it, and I have dropped it a few times. They're really cheap, like $20 light panels off of Amazon. So I actually used my iPad as a source of light and was able to create the flats with that, which was great. iPad and a t-shirt. Now, I'm not sure exactly what happened. Maybe it's because there's just a little bit of data and everything is just kind of wonky from me shooting in moonlight, and it was kind of high clouds. I was just really trying to use my scope. You guys know how it is sometimes. You just want to play with your toys. So I had to actually bring my value of my flats. I usually take flats at like 30% histogram, which is kind of like what a lot of people do. I actually had to bring this down to around 10%, which was an ADU value between about 8,000 and 12,000. Now, the ADU value of the images is around 5,000. So I'm not sure why it didn't just kind of work out. It seems to always do, because I checked other images, and in the statistics inside Pixinsight, if you go to process and just go down to statistics down here, you can actually see that stuff. And, you know, it's helpful to know this stuff. You know, I try not to get, too advanced on the channel here right off the bat for people, but you can see that, this whole image, after it was all together, right now has pretty, the average median values that you'll see, like around 4,000 or 5,000. Now, this will change in a little bit. Went through and done a little bit of playing around with this, and you can see that it's still not 100% correct, but it doesn't look too bad. What we're going to do is I'm going to load up my process icons that I have here, and we're just going to run a quick dynamic background extraction on this. I tried to run a regular automatic background, which is just a simple, easy one click, and it just didn't work. But this seems to do a pretty good job. So the first thing I want to do though is just crop this just down just slightly, just to take off some of any kind of like stacking artifacts, which there shouldn't be a lot because this is only like an hour's worth of data, which is probably hurting us as well. And then I want to run a quick auto color. So we're just going to go to the auto color script and run that. And that's going to kind of just equalize things a little bit more. And then we'll run the dynamic background extraction, and that will finish things off. And I've already done this to show that it actually will get rid of that stuff in the corner and kind of just correct all this stuff that's going on. All right, so now we are all auto colored, and we're going to go ahead and bring up the dynamic background extraction, and we're going to set our target to division, replace, and discard. And I want to increase my sample size to about 150. And we'll go through here real quick and just kind of delete all of these that are inside the actual nebula itself, because we don't want to throw off the dynamic background extraction with a bunch of data that is of the wrong color. So don't mind me while I do this. So now we have our markers in place here. We're not over any bright stars. We're not over any nebula. There is some nebula like right around in here though, that I can definitely tell that is not part of the correction of the flat. So we'll just maneuver those around a little bit. And I think that looks pretty good. So I'm going to go ahead and pull this down and save this, because I'm also going to want to run a subtraction on this just to make sure that I get rid of everything. And if we go ahead and close this and if restretch it, you can see, boom, it's taking care of all of that now. And we have a very good looking image that is ready to go. So I just brought that back up and we clicked on subtraction, and we're just going to run this on here again. And not much changed that time, but it is all good. So we'll just go ahead and close that out and restretch it. And there we go. You can see that if we go all the way up into our corner, we are all good. We got rid of all that stuff. We've got nebula coming out here, and you know, everything was pretty good. I did decide to go ahead and change the position of my off-axis guider. These are some flats that I was just taking out there now, and you can see instead of it coming down further down into the image like it was, I pushed the prism up a little bit so it's not affecting as much of the image. I am using a 290mm guide camera, so it should pick up plenty of guide stars still, especially using this wide field scope. Should not be a problem. But of course, we're not going to really know until we get out underneath the stars again. So there you go, guys, some real-time troubleshooting. We found a bad tablet. We hopefully made a good adjustment on our actual prism of our off-axis guider, and we kind of had to work around some issues because the typical way we did flats didn't work this time. Hopefully next time it will, and I won't have to go through this, and if not, I will know how to fix it, and so will you. So thanks a lot for stopping by, guys. Thank you to all of you who are subscribing. Peace.